So now we are going to move on to properties of logarithms. Some of these properties we actually saw in the last section. First and foremost, though, before we throw a lot of equations at you, I just want you to understand that the log is just a number, and it's just defined by the equation it solves. The log of m base a is just a number that if you raise a to that power, then you get m. Okay, so the log of m base a is just the solution to a to the x equals m, and you want to think about this in the back of your mind when you do all these things. This is equivalent. X equals the log of m base a if and only if a to the x equals m. And you'll see that these properties of logarithms that we have over here are just ways, another way of stating the equations over here in their exponential form, which we already know to be true. For example, we already know that a to the 0 is 1, so that just means that, under this equivalence, that the log of 1 base a is 0. We know a to the 1 is equal to a, so the log of a base a is 1. So a to the minus 1 is 1 over a, so that's why minus 1 is the log of 1 over a base a. Okay, so these, hopefully, I think we've covered these in the last section. Now, for the next three properties, the reason why the log of mn is the log of m plus the log of n, the reason for that is if m can be written as a to the r and n is written as a to the s, then of course that the logarithmic form is this: r is the log of m, s is the log of n by definition. And then we know that mn, well, that's a to the r times a to the s. Well, that's going to be a to the r plus s. We just add the exponents. But the exponents are the logs, so that's why we're adding the logs. Similarly here, m over divided by n is a to the r divided by a to the s. That's a to the r minus s. And so that means we are subtracting r and r minus s, so we're subtracting the logs. And then finally, m to the k is, we're taking a to the r and we're raising that to the kth power, so we multiply the exponents. Okay, so that's why we have the kr is the log of m to the k, but that's just going to be kr is just k times the log of m. So that's why you can pull this k out in front. Okay, so I just want to use these properties as a to do these following examples. So here we have the log of 2 plus the log of 7. By the way, I should say it's very important that all these properties only work if a is the base a is the same. This won't work if you have the log base 3 plus the log base 4. So something like that. But here we have the log. Both of these logs are base 10. They're common logs, so this is going to be the log of 2 times 7, which is the log of 14. Okay. Here we have the difference of two logs. This is going to be the log of 28 divided by 7, and that's the log of 4. Here we have 3 log 4. Well, we can bring the 3 up in front, so this is going to be the log of 4 to the 3rd power, which if you can either use a calculator or work it out yourself. This is the log of 64. For this next one, we have that we have to do a couple steps. We can take this 1/2 up in front here so this will be the log of 25 to the 1/2 plus log 6 minus log 13. Okay, and 25 to the 1/2, that's the square root of 25, which is 5. So this is the log of 5 plus the log of 6 minus the log of 13. And this, when you add these two, this is the log of 5 times 6, and then you take 5 times 6, divide by 13. So this is going to be the log of 5 times 6, divide by 13, which is the log of 30, divide by 13. Okay. And then finally, we have 1 minus the natural log of 5. Okay, how could we possibly write this as a common log? Well, or a natural log? Well, 1, of course, is the natural log of e. Okay, that is a direct consequence of this, where when you take a case where a equals e, this is the natural log of e is 1. So the natural log of e is 1, so this is the natural log of e minus the natural log of 5, which is the natural log of e divided by 5. Okay, so you can do it that way.